So welcome to our instructor training class for scaling, spring 2018. Most of the folks in this course have already been in several Cisco instructor training courses at Stanley Community College. My name is Kelly Calden, and I am your instructor for this class. We are going to do a couple things. We are going to first just real quickly go over the basics again of how you interact inside of the NetAcad system. All of you have already completed your Moodle assignment, so if you will, please just every week or two log into Moodle just to show attendance. But our primary areas we will be working in will be netacad.com and netlabs.stanley.edu. So to begin with, let's look at NetAcad. Inside of modules, you're going to see all of the different items that I want you to complete. Now, this goes to, when you're looking at Chapter 1, there are 2 packet tracers and 2 labs. One of the things I want you to know is that in some of these chapters where there's 6, 7, 8 packet tracers, if you do not do all the packet tracers, I'm not going to have a heart attack. All right, if you do at least 1 or 2 of them, I prefer 2. And definitely if there's any skills integration challenges, always do the skills integration challenge packet tracers, because those really challenge your abilities to do the configurations. But I'm not gonna have a heart attack if you don't do every single packet tracer inside of the class itself. Now, the labs, however, that's completely different. The labs I want you to do. Many of the labs do require you to use NetLab. Some do not. For instance, this layered network design simulation does not require you to do a NetLab. You actually go in and create your own layout, and you can use just Word or you can use Visio, whatever you happen to have. But many of them do require you to actually go into NetLabs, such as configuring BTP and DTP. So there's a NetLabs lab that will, actually that was a packet tracer, I clicked on the wrong one, that will require you to go into NetLabs and use the actual equipment inside of NetLabs, you can see here. So be aware of that, be aware that we are, those are not optional. The labs need to be done inside of NetLabs. Okay. So in NetLabs, oops, wrong one. I logged in as the wrong thing. Let me pull this over here and I'll log in as me. But packet tracers at least do 1 or 2. NetLabs, or the labs themselves, do all of the labs. Remember, if you are doing NetLabs and you are prompted for a port test, make sure you do that port test. Otherwise, the NetLabs will not work. You're in a class, and in that class you have, we'll go down, it's SP17, ITC Spring 18 Scaling, and inside of there, I'm just going to grab somebody. Charles is not here, but here's all the labs that are available. So you've got 2, 1, 4, 5, all the way down through the 10 labs with multi-area OSPF, and then we've got 2 separate skills-based assessments that you will be working on at the end of class. But again, just to very quickly show you, click, and then you can schedule your lab wherever you want to schedule. Right now, there is an issue on switch to a pod 3. It'll be resolved tomorrow, but just be aware there is an issue. Also, remember, too, that you can go further into the future. If you want to schedule something for Sunday night, you can do that. You don't have to schedule just at this particular time. You can schedule into the future, and you can schedule, like I said, up to as far along in advance as you want. The only thing I ask is don't have overlapping schedules if you can help it, simply because you can't be in 2 pods at one time, so there's no need to be scheduled in 2 pods. Be aware, too, that this is real gear, so when you schedule this gear, it will take it a little bit to boot, and then I will show you in a minute when we go in and actually look at the lab itself. And I can jump in the lab and show you. Here's a lab that one of my students is doing. Be aware that the lab content will say this has been updated for use on NetLabs. So make sure you're using this when you go through the lab itself. If you don't, it could be slightly different than what's inside of our curriculum, and it won't work. So just make sure, for instance, many of the labs say connect a console cable to R1. Well, in NetLabs, you just click on R1. You don't have to actually connect a console cable. So be aware of that. It will change those items. Almost everything else is exactly the same, with the exception sometimes of an interface. But in most cases, it is exactly the same. So again, once you're inside of NetLabs, Be aware that it's going to take a little while for it to boot, and when that's happening, you will see it saying starting equipment pod, please wait. And that can take up to 5 to 10 minutes, depending on the pod itself, and depending on how quickly or how much stress the system's under. But most times 5 minutes and it's ready to go. All right, so this is our primary area we'll work in the class. It's under this Moodle section. You'll read the chapter. You will then do the packet tracers and upload them. Please be aware again on the packet tracers, when you complete a packet tracer that has a scoring component. So for instance, you'll look at this challenge lab here. I'm going to open up the packet tracer. Takes it a few seconds to open, but it's actually opening on my other screen, so I'll pull it over as soon as it's open. So here's the challenge, and then here's all the different items the challenge wants you to do. Okay, you'll notice my completion is 0 to 75%. Please be aware when you get finished with the packet tracer, I do want you to do File, Save As, save it with your name, .pka, upload that into Netacad on that upload link. In addition, I want you to do check results and look at the assessment items and actually go in and use your snipping tool to just create a quick snip of that and upload that as a file along with your .pka. That just saves me a lot of time of having to open up every single pka and do a check result on it. Now, if you miss some items, I can also look at this and see what you missed and then make suggestions as to what you have missed. So that's something to definitely do. Yes, Mark.
The worksheet that you download with this as well, sometimes they have questions in it. I know in the past we've been asked to do that. I just need to know for this course.
Just stick them in a text document and throw them as another upload.
Okay. All right.
That's all you have to do. Just put them in a little. You can put them in Notepad. It'll be fine.
Okay.
Just answer it. And most of them usually have maybe 1 or 2 questions at the end. And again, so just take that and upload it as a little Notepad document or Word, whatever works for you easiest.
Okay.
Okay. So on some of these packet tracers, you will be uploading possibly 3 different files: the pka itself, the snip, and then a short Word or text document with the answers to the questions. So that's the basic format of what we're going to be doing in here. The good news and the neat thing about this particular course is this course takes and expands upon our knowledge from Introduction Networks and Routing Switching Essentials and starts looking at how we scale networks out to become bigger and some of the different problems we encounter and some of the different protocols and methods that we use to do scalability. We're going to talk about items such as obviously LAN design. We're going to talk about VLANs and 2 concepts that used to be inside of the CCNA for as long as we can remember. They took it out, now they brought it back. But VTP, VLAN Trunking Protocol, and DTP, Dynamic Trunking Protocol. And then we're going to talk about HSRP and Ether Channel. We're going to talk about Spanning Tree Protocol, again, something that was heavily in the CCNA for a while and then was removed and is now back in there. Not really a super deep topic, but we are going to talk about that. Well, it can be, depending on how you do it. We're going to look at dynamic routing again, and with dynamic routing, we're going to move from the very simple protocol RIP that we talked about inside of Routing Switching Essentials. We're going to get into protocols that are scalable, which for Cisco is EIGRP and OSPF. We'll look at single area OSPF and multi-area OSPF, and then finally troubleshooting and tuning OSPF. So really, as far as the number of new topics, there are not a huge number of new topics, and really a lot of the concepts here just fill in parts that you have been missing from Routing and Switching Essentials. Before we move on and do a quick look at Chapter 1, are there any questions about the format of the class or how things will go from here? Nope. All right. Well, let's just jump right in. Let's jump into Chapter 1. Now, one of the things when we talk about scalability and we talk about doing scale, one of the things, anytime you build a network, I tell my students to realize they're going to grow like rabbits. You've got four computers today and a server. Tomorrow you'll have 14 servers and 200 computers. That's just the way it works. It also is one of these things that you will find that the network you put in, even in a small business, this is success. I think the best way to look at it is imagine at your house, if your internet goes down, what happens? Your kids start screaming, your wife starts screaming, you know, everybody goes ballistic because the internet's out. So we've become pretty dependent upon these networks. We also have built the need for these networks to stay up 24/7 and to be able to add on to them fairly easily. So we keep adding devices in our houses, everything from cameras to you know, multiple phones, multiple tablets, to the point where, you know, we've got 10 or 20 devices in our houses easily. One of the big ways, and this is something that has been a part of both this class and used to be a part of the CCDA, Cisco Certified Design Associate, was this hierarchical design model, which uses a CDA designation, or core layer, distribution layer, and an access layer. Excuse me. Each one of these layers has a specific function. The access layer is the layer that provides access to end host devices. That's how we usually define it. You may do port security here, you may do basic port filtering, but this is just the end layer device connectivity. The distribution layer is a layer where you're doing security, you're doing inter-VLAN security, you're trying to do security policies, and you still want redundancy. The core, we typically think of the core as being high-speed switching and routing. So your core, you want to try to take away anything that would slow down the core. Now this model has changed quite a bit because of the fact that now we have server blocks off this core. We also have many networks that can't afford to build this very scalable network design. I mean, this is super scalable. You could add another distribution layer switch, put in multiple links, drop some access layer switches in, and have a very scalable design. However, when you start buying, you know, 6800 series switches for the core, and they're $50,000, $60,000, $70,000 a piece, many people can't afford to have a clearly defined core and distribution layer. So sometimes you end up with what's called a collapsed core, and that core is a core that combines both the distribution and core functions as one item, and then your access layer connects directly to that. Very common in smaller businesses and in businesses that simply can't afford a fully redundant network. When we go to design for scalability, some of the things we're going to want to do is look at multiple links, and using the hierarchical model to do that with, looking at link aggregation. That's what this is ether channel. Link aggregation is taking multiple links and making them appear to be a single link. We're going to look at IP addressing schemes to make sure we can break our networks down and summarize across scalable routing protocols. And then we may look at some other items such as modular equipment and wireless LAN controllers and how we're going to handle this influx, especially of huge amounts of wireless clients onto our network. So planning for redundancy, that is multiple links. Now, one of our entire sections, when we start talking about spanning tree, deals with this concept of LAN or layer 2 redundant links. And one of the problems we have is as soon as you put in redundant links like this, especially at layer 2, there's no layer 2 time to live mechanism. When you think about a data link frame, data link frames have no TTL on them. So if you have a broadcast and you have true loops at layer 2, they will just continue to go and will create a broadcast storm. You're going to learn that the spanning tree protocol is a protocol that was designed to prevent those layer 2 loops. Because we want the links, we want the ability to have redundancy, but we have to have a way for there not to be loops and for links to go up and down as needed. Spanning tree protocol is going to be that protocol that allows us to do that. We want to set up the smallest failure domains as we can. In other words, if a single device fails, how much is going to go down? You know, in this case, if you had a single router, then obviously if it went down, the whole network goes down. The question becomes, oh, can you afford to put in dual routers and dual internet connections? It really comes down to how much money you've got. Scalability is in many ways and shapes dependent upon the amount of money you have to spend, especially reliability. Ether channel, this is that aggregation technology I talked about, which is used to make, let's imagine these are 2 gigabit links. With Ether channel, we can make these links appear as one physical link to the switches, which is good for spanning tree because they don't, they won't see this as a loop. And 2, it can also use it as a 2,000 or 2 gig send, 2 gig receive. Depending upon the switches themselves, will depend upon how many links you can put together, between 4 and 8 in most cases. And this does work all the way up with 10 gig. So you can go, if you do an Ether channel with a 10 gig link, you can end up with 20 gig send, 20 gig receive. Any questions so far? I don't want to bore y'all to death if you know all this. So this is something that's new that you haven't seen before, because we've talked about a very simple routing protocol, RIP, and RIP sees everything as one big network. OSPF does by default if you just use area 0, but OSPF does have the ability to actually break your network into multiple areas, what's called a multi-area network. Then if you planned your IP addressing scheme correctly, in other words, you designed a scalable IP addressing scheme, you're able to take each one of these sections and summarize to the networks inside of it. So instead of advertising, let's say there were 100 networks in area 1, instead of advertising 100 networks in the area 0 and then over to area 51, if you can summarize that down to 1 or 2 routes, those summarized routes can then be injected into area 0, and then area 0 can then tell R2 about it, and vice versa. So you can end up with a very small routing table if you have designed your network correctly and have it designed to be scalable. EIGRP has some of the same concept, but it's not quite as elegant when it comes into the multi-area. Now, EIGRP does have the ability to what's called protocol-dependent modules, and that's the ability to run multiple different layer 3 protocols, V6, V4, and all of this we will actually talk about as we get into EIGRP and OSPF. So I keep clicking the wrong button. Sorry, folks, my hands aren't working right today. As we look at switch platforms for our LAN designs, we're going to see that there are multiple different types. There's obviously the access layer switches, which are typically, access layer switches are fixed switches, are fixed port switches. We're going to look at data center switches, or our distribution and core switches, which are switches that are modular. Cisco now owns Meraki, so they've got some cloud managed switches. And then they've got everything from data center switches again, which are some of their 5548s, a lot of, not the Catalyst, but the Nexus series switches. If you look, here's a fixed configuration switch, which again is typically what we use for our access layer switches. Modular allows you to put in blades. Okay, this is a 68, 65, 6800 here. You can slide in multiple blades. These are different chassis that have different supervisor engines in them. Now this is an interesting little thing. This is called Stackwise technology. And with Stackwise, what you can do is you can take multiple switches, you can connect them together with these Stackwise cables. Almost looks like a token ring setup. You ever played with any token ring? And then these switches all appear as having a single backplane. So you can actually put what would have been fixed port switches together using Stackwise to make them appear to be a bigger switch. Now, what do we use to decide upon the switches we're going to buy? Well, one is port density. How many ports do you need? How much money do you have to spend? Do you need power over Ethernet on all the ports to power your phones and or your access points? How reliable do they need to be? What's the port speed, which I would say don't buy anything. It's not at least gigabit, obviously. Frame buffers, and then scalability. What can you do if you do need to grow? What's your projected growth? If you know you're never going to have more than 10 PCs in a room because of space, well, then you could go in there and put in a 24-port fixed level switch, a fixed module switch, and not have a problem. If you know there's going to be additional PCs added, you may want to go with a modular switch design that lets you add in additional capacity down the road. Because it's cheaper to do that than completely replace the entire switch. Here's a 24-port fixed. Here's a 48-port fixed. This is a modular switch that can be up to 1,000+ ports, depending on what blades you put in it. And these blades can be mix matched, so they could be all 10 gig here on these, and then these could be 100 megabit here, or 1,000 or gigabit or whatever. Or you could put in all 10 gigabit if you were really want to spend some high-end money. Now, this is one place that you have to be very careful, especially with vendors. And one of the things that you will see is you will hear a concept called wire speed switching. The backplane of some switches are not able to handle every single port forwarding all the information that it can at one time. In other words, if you've got a 24-port gigabit switch, in order to do true wire speed switching, it would need a 24 gigabit per second backplane. This is where you get some switches and they'll go, well, this is so much cheaper than so-and-so vendor. Well, the reason is because the backplane actually cannot do wire speed switching. Now, if you have 24 ports, are you going to have 24 gigs of traffic going through every port or going through the ports? Probably not, but that is one way you can be careful to make sure you're comparing apples to apples. Look at the actual backplane forwarding rate, or the forwarding rate of the switch itself. For instance, if you had a 48-port switch and it only could do 32 gigs of backplane traffic, well, it's not full wire speed across all ports. Okay. And again, normally they don't, but some of the lower end switches, that's how they get away with being cheaper, because they have much less forwarding speed than what you would need. PoE, this is where you can run power out to your phones or out to your access points. Your switch has to support this natively. It is not something that you can, well, I won't say you cannot. It's not something typical that you can add to a switch. So if you know you're going to need power over Ethernet, then you need to have PoE capability so that you can plug phones in and power your phones off of it. And since most people are going to voice over IP phones, that's a big thing. Now, there are also some, too, that can have PoE pass-through. And so actually what happens is you've got like a PoE injector that passes through information like this. You've got an upstream switch that's PoE passes through. Most of the time you want your PoE to be on the switch port that you are connecting the device to. Layer 3 or multi-layer switching, that's what this means. It's the ability to handle layer 3 switching. Even the 2960 series that we will learn is able to use very basic layer 3 switching. You'll be able to set up some switch virtual interfaces by loading a special SDM on the 2960. And you'll do that as part of class. All right, now what about a router? Well, a router is a layer 3 device. It does broadcast containment. It does logical grouping based upon IP addresses, and it routes between different locations. Now, one of the things I'm going to do here is, in this particular setup, they're talking about branch routers. These change daily, so it's just one of those things where a branch router is just going to be a lower-end router that doesn't have as many features. Could be something as low-end as an 800 to as high-end as a 4321 at a branch, depending on what you're doing. Network edge routers are getting into more high-end routers. So you're looking, depending on the systems, could be Nexus, could be higher-end 9000 series. And then you've got these I think these things are called CRSs. But these service providers, these are about $1 million a piece for these routers. So these routers are amazingly fast. So we're seeing 800 series, 2900 series, 29s being EOL, 2900s are being replaced with the 4300s, which if you've got any 4300s, one of the things they've done is they've actually put an external power brick on the 4300s, and I do not like it at all. But, you know, they did it to make it a smaller motherboard and smaller form factor, but it's going to be a pain when you have to find somewhere to put those things on a rack. The SR1000 is the aggregate service router, and then you got CRS, which is a carrier routing system, which is for the AT&T, Sprints, and the huge networks out there. This is again a blade server or blade router, so you can put in multiple blades depending upon what you want and need. The good news now is that iOS 15 is a single iOS that you can then just enable different feature sets on. If you are a Cisco Academy, by the way, you should be part of Academy Maintenance. The Academy Maintenance Agreement allows you to download for free the iOS images that support the labs in the Cisco Networking Academy. This does not mean you can download every iOS you want. It means you can download the ones that have been identified by the Cisco Academy as needed to complete the labs. So be aware of that. If you don't have that at your school, contact me, and we will get you set up on the Academy Maintenance Program so you can have that. Now, review here, inbound versus out-of-bound management. Out-of-bound will be the console port or the auxiliary port over PSTN. In other words, anytime you're not going over the network, you're going to be out-of-bound. Inbound management is when you're coming through with SSH or Telnet, hopefully never Telnet, but you're coming into the device through an IP address, typically SSH or HTTPS. I'm not going to spend a lot of time on this because you know these commands. I mean, this is the basic router config. We're going through setting up enable secret, host name, passwords on the consoles, passwords on BGY lines. Be aware in iOS version 15, by default, there's a command under the BGY lines that says transport input none. If you do not change that to transport input SSH or transport input Telnet, which obviously we don't like using Telnet, but it would probably be transport input SSH, you can even go in and configure the passwords on the BGY line. And if you forget to turn that transport input none into transport input SSH, it will not work. So make sure you're aware of that. See that a lot with students when they're trying to get in. Show running config, and then now they're just going to run through some of the basic commands. Show IP protocols to be able to see what protocols, routing protocols running. Show IP brief, show IP route, pipe begin gateway shows the routes that are available. Remember, these C routes are connected. That's the network's directly connected on an interface. The L local route is iOS 15 specific and shows you the actual IP address on that interface. Show interfaces, and then you can do gig 00, and it will show you the IP address on it with the mask. It will show you what encapsulation it has, whether it's full duplex. One of the big things out in the real world is looking down here at runts, giants, and throttles. Runts would be collisions. Giants are probably, you see a lot of giants when one side's been set to jumbo frames, the other side is not. So that, you get problems there. You see a lot of CRCs, and I would start looking at some issues with possible distance run items and those types of things, but you can take a look at those. Here it is showing whether or not there's access list set, okay, on a particular interface with that same command. This is my favorite command by far. I saw many problems with it. Show IP brief. I just wish it would show me the subnet mask assigned on the interface. I still don't know why they don't just throw the subnet mask on this command, so it would be so much better so you would know. Remember, all router ports begin their life shut down, unlike switch ports. So if you do not do a no shut, they are administratively down. Also remember this, the first item here is the layer 1 status, the second item is layer 2 status. So you can have up, down, and that would be you've got a layer 1 carrier signal, but you do not have matching layer 2 protocols. There's a layer 2 authentication issue, possibly with PPP, with CHAP, which you will learn about in the next class. You can have down, but you can never have down, up, because if you don't have layer 1 carrier signal, you will not have layer 2 being up. Show protocols, show your protocols. If you show IP protocols, it show just your IP protocols. You're getting down in the weeds if you start doing show CDP neighbors, but it is possible. CDP is a Cisco proprietary layer 2 protocol that is used to discover neighbors. But you can do show CDP neighbors to see all your directly connected neighbors. It will tell you what the capability is. It will also tell you what the platform is. You can even do a show CDP neighbors detail to really get a large amount of information about the connected neighbor, including its IP address. Switch commands, almost exactly the same. The only thing different here is on a switch, you put the IP address on an SPI on a switch virtual interface. They show here the example putting it on VLAN 1. I would never use VLAN 1 for the management of a switch because that is the default for all of the switch ports. So make sure you don't actually do this in the real world. Put it on a management VLAN and then move everyone off of that switch or off of that VLAN 1. Show port security, showing you some of the port security, whether or not what the violation mode is, number of MAC addresses that you can set, whether or not they're sticky. All of this was items we looked at in semester 2, which is Random Switching Essentials. You can look at the table here. You can see whether or not they're sticky, dynamic. You can see different items of the show interface. Shows you all the different speed, duplex, IP address that's on the interface. And you can even do a show MAC address table to see what MAC addresses have been learned on what ports. Which can be used if you're troubleshooting things like someone trying to do a man-in-the-middle attack or a missing MAC address or something of that nature. And that really is Chapter 1. I mean, you look at basic switch configurations, and what they're going to have you do in Chapter 1 is do a skills integration challenge, which has you do all the things we've done in Routing and Switching Essentials and just get you back up to speed on those items. Are there any questions about Chapter 1 and scaling? Be aware, one of the things I do want you aware of is your due dates are shown in modules. Okay, so when you look here, you'll see that February 18th is the due date for this first packet tracer, and same for these labs. Again, be aware these due dates are not absolute. If you miss it by a day or so, or 2 days, or 3 days, I'm not going to have a heart attack. I'm not going to give you a 0. I've just found if I give no due dates, people tend to do what I do, which is procrastinate forever. So if you'll stay fairly close to these due dates, it'll help you get done by May 9th, and then you can have some time, some rest time between then and May 30th when we'll start our connecting class. Okay? By the way, I did post the dates for the next round of classes. It will be May 30th through August 15th, and they are posted. Unfortunately, they will go up to $185 per class at that point because we're moving everything to that particular price structure. So, Joseph, Mark, William, do y'all have any questions whatsoever for me about Chapter 1, about the scaling class, about anything dealing with the Academy right now?
I don't have anything right now.
Okay. William, you got anything? I'm going to stop sharing, and I'm going to actually turn the recorder off.